Okay, for C and D, letter C wants us to calculate K for the reaction. And based on our answer from B, we can now do that because we can use our previously found exponents to help us solve algebraically for K. In order to solve algebraically for K, we have to plug in something for rate, something for concentration, and something for concentration. So to do that, we're going to use experiment 1's data, and we're going to plug in those numbers, and that will allow us to algebraically solve for K. You could use any of these experiments that you want, but I just use experiment 1 because it's the first experiment. So the rate we're going to choose is 1.3 times 10 to the minus 7 molar per second is equal to K times, remember concentration means brackets, or the brackets means concentration in molarity. So it's 0.10 molar to the first power, and then 0.10 molar to the second power. So now we want to algebraically solve for K. We're going to do 0.1 squared times 0.1. So if you simplify this, we're looking at K times 0.001. And the units here, molar to the first times molar squared, is going to give us molar cubed, is what we're simplifying to. Over here, we're still sitting at 1.3 times 10 to the minus 7 molar per second. When we divide, we're going to divide by 0.001 molar cubed and divide by 0.001 molar cubed. Now, the K is annoying, the rate constant is annoying in terms of its units. It's not always the same. We got molar cubed here because this was molar to the first and molar to the second, but when we write rate law expressions, that's not always guaranteed. It could be a 1 and a 1, it could be a 2 and a 2, it could be even a 0 and a 1 or something like that. So the units on K vary and they're kind of annoying to deal with. So getting the correct units on K is super important. But for right now, we'll just look at the numerical value we're supposed to get. 1.3 times 10 to the negative 7 divided by 0.001 is going to get us 1.3 times 10 to the minus 4. And now we have to figure out the units on K. So we have molar divided by second divided by molar cubed. So if we go over here, molar over second, right? And we're dividing it by molar cubed. So we can simplify this to be molar divided by second times molar cubed. And then from here, we could do a little canceling, right? We can get rid of this molar and we could change this 3 to a 2. So the final units on this are going to be 1 over molar squared times second. We switch this around simply because molarity usually comes before seconds. But if you left it as second times molarity squared, that's perfectly fine as well. That would be acceptable because the units are correct. But this would be like the traditional way of reporting the units. Now, no one likes looking at fractional units, so what we typically do is we change this into linear units by just calling it molar minus 2 times second minus 1. So I would say this is probably the more common way you're going to see the answer. If you put the answer like this, that's acceptable as well. But you should be aware of both of these and how to get to them. So over here, we can put in our units of molar minus 2 times second minus 1, and we can set it equal to K. So this would be our answer to letter C.